we are going to have the last part of the fourth section today about visual processing in the brain. I'm going to talk about information selectivity in visual processing and give you a sense about how this is an important part of visual processing. Excuse me. Just see this eyeball in the middle. Just try to be focused to this eyeball in the middle. I'm going to show you a picture, and then I'm going to ask you a question, okay? So just be focused to this eyeball. Okay. The question is, have you seen a baby in your visual environment? And whether the baby is on the right side, on the left side, or on both sides. So 4 options: no baby, baby on the left, baby on the right, baby on both sides. Just type your answer to the chat space. Okay, good. Let me go back to the picture. Now, can you see the baby on the left side as well? Okay. So the question, people have tested that in different environments, and they show that most of the people cannot see the baby on the other side. And the question is why? Why we are not seeing this kind of baby here? Why we see this baby in a better way? They are discussing about something that we call crowding. So when we have pieces of information, different pieces of information in one side, and even those signs and the other things that we have here compared to this side, sometimes just we overload the object recognition capacity of the brain to be able to see all the objects that we have in the environment. Okay? So there is a limited space in terms of processing. And if we occupy that limited space, then there would be problems in terms of how these things are going to be processed. So that is one side of that problem. So let me just go and give you some other kind of aspects of that visual processing that could be important in a way that how we kind of inform some other behaviors in the real life. Okay, let me give you another kind of study that people do. We can give people stimuli related to face or related to place. Okay? If I go from place to face here, there would be an activation in the fusiform face area and reduced activation in place area, paracriboncaudal place area. And if I go from face to house, there would be a higher activation in the place area in the brain. So we know that phenomenon from before. So we know that as soon as we just change the house to face or face to house, we have these changes in the activation. And we are talking about seconds. So the x-axis is about seconds. And we know that that is probably, is this EEG or FMRI? What do you think? Is this EEG or FMRI? Is this EEG or FMRI? Yeah, obviously it is FMRI as we have this here, but this is FMRI because the sampling is in the orders of the seconds. If I go back to the slide that I showed you kind of last part, let me just go back to this. This one is in milliseconds. You see that here? The information is about milliseconds. This could not be fMRI. This is definitely EEG or MEG. Without EEG or MEG, we cannot have information in milliseconds. And that is going back to the question that one of the students asked in the first few minutes of the class in terms of which instrument we use. Depends on the question. So if we are talking about milliseconds of information processing, we are talking about EEG. But if we are interested to have the flow of information in different parts of the brain to other parts in milliseconds, That could be happening only with MEG. Without MEG, we cannot do that. It's really hard to do that with EEG, just the EEG, just simple EEG. But we can do just these simple ERP assessments with EEG. So that is something that we can do with EEG. Just going back to the slide that we had right now in terms of the MRI signal. So we have been talking about changing phase to place and place to phase. There are specific, let's say, glasses that can be used, not really kind of complex glasses. There are just kind of glasses with yellow, with red or green glasses. So you can the shield or the lens would be different in a way that when you have these glasses and you have the complex picture of having both red and green pictures superimposed to each other, okay, at the same time. One part of the brain, one eye would receive the green picture, which is the face, and the other eye would receive the red one, which is the place, okay? And when we ask people to see these pictures, I mean, in terms of one eye is receiving information in terms of the place, the other is receiving information in terms of the face. And it's a complex thing for brain because brain is not developed for these types of, we call visual rivalry, competition between two eyes in terms of the information that they are receiving. How the brain is processing that? Do you see these things mixed together or do you see them separate based on the dominance of your eye? What do you see? If you do this, you will realize that you will start to see the face for a few seconds, and then home for a few seconds, and then face for a few seconds, and home. So there is something like a competition between these two parts, okay? And if you record, for example, put the bottom, as soon as you feel that there is a face changing to home, just push the bottom. And then home to face, push the bottom again. Whenever you have the changes from face to, even you can have two bottoms, face to home, this bottom, home to face, this bottom. So you can just report when you are seeing those, and they are stable, so they are not changing. So you see the same picture, but your brain is perceiving them in a rivalry kind of way, so they compete with each other. For a few seconds you see one, the other few seconds you see the other. So you are reporting that with the bottoms. And if we do this, whenever people are reporting that the house is changing to face, just in the kind of orders of milliseconds before or after. So that's another interesting question, whether it's going to be just before or after. But what you see here is we have the same changes in the activated area. So what we feel in terms of we see house or face is changing to house, is because the brain is changing in terms of the process that is happening in the brain. So it's exactly like kind of having fusiform face area taking over or parahippocampal place area taking over. So it seems that they are competing with each other because they are receiving, one of them is receiving information from one eye, the other receiving information from the other eye. So they are competing from each other to present you one of these pictures, present that one of those pictures to the level of consciousness that you can have. And it's amazing that these rivalry or non-rivalry, as I kind of showed you before, they almost the same in terms of the activations. Here we change the experimenter or researcher change the stimuli from house to face. But here the brain is changing the house to face and face to house. But the activation is the same, because when you see the face, this is the activation. Whether you are seeing that because you are present at face or your brain is presenting face to your consciousness. And that is an interesting piece of how these kind of pieces of information could be selected from the environment. So there is a level of selectivity in terms of the information that you are perceiving from the environment. Let me show you another task, which is going to be the last slide of this presentation today. If you have seen this experiment before, please do not tell people the answer, okay? But if you haven't seen that, that would be nice to see it. It's an attention task. There are two teams, one with white shirts, the other with black shirts. And they are handing the basketball game to each other, okay? Just count the numbers of the time that the white team is receiving the basketball game and passing that to another member of the team. So the number of the time that one person from the white team is passing the ball to the other person, so the number of the times that they are passing the ball to each other. So you are supposed to count the number of the times, and you are supposed to tell me the number on the chat space. So try to record the number of the times in the most accurate way, okay? So I'm going to bring up the task. For those who haven't seen the response, just report the response. How many times have you seen that? The correct response is 15. But I'm going to bring back the video and start to show it again. And now just try to see if you can see something abnormal here. And this is a really nice study that is being designed by Dr. Simmons. And you can follow his works. He has a website discussing about these things. He has a book also about that phenomenon. So we are seeing exactly the same video again. Now, do you see the gorilla? Okay, those who haven't seen the gorilla in the next step, in the next presentation, just tell me in the chat space, those who haven't seen the gorilla in the first time that they saw the stimuli. I've done this experiment in a group of really senior judges. I had a workshop with a group of judges. We have been discussing about the role of cognitive neuroscience in judicial system and how it's important for us to know about the cognitive system when we are in the position of judgment about the different levels of eyewitness testimony or the other thing. So it was a really interesting workshop. I'm not going to discuss that right now. But it's amazing that there have been something like 20 judges, and to my best memory, something like 80% of them didn't see the gorilla. And after the exam, I showed them the gorilla and I told them how unreliable could be visual information in terms of not paying attention to something really big and striking in the information that we have in the environment, in a way that is amazing how information could be neglected in the environment when we are not attending to the information. So that's another really important phenomenon in terms of, and you can do it in your family. You can easily find this video if you just search for Simmons and gorilla. So you can find the video. Just try to find the video and just show that video among your friends or your family members, and see how many of them could see the gorilla if they do the task in the right way and count the number of ball passing. And then they can give you that can give you a really good insight in terms of how really important pieces of information from the environment could be missed when you are not paying attention to that. And that gives us an important last message when we go back to the discussions that we are talking about in terms of the selectivity of information and what we discussed about before in terms of what we call top-down voluntary attention. So we discussed about how top-down voluntary attention could make a significant effect in terms of what are the pieces of information that could be processed and go towards the other pieces of the brain, and how important pieces of information could be easily neglected. And then the question would be, okay, how this system, how this top-down voluntary attention is working in selecting the information that are happening in the visual processing. These are going to be something we'll discuss about next session, how this selectivity is going to be important in terms of how we perceive the environment around us. Okay, thank you very much for your attention. I tried to be on time as much as possible. We are just a few minutes out of the planned time that we had for the session today.